Hello everybody, welcome to the Quantum News Weekly Recap for January 11th, 2025. This week we have some huge news coming out of Nvidia. Their CEO made some comments and some companies responded. I'll get into that. We have record temperatures for superconducting qubits and some new quantum computers and more. So let's jump right in. On January 8th, Jensen Huang made comments about the timeline of quantum computers. He's the CEO of Nvidia, and someone asked him what he thought. He said that between 15 to 30 years, we'll have a useful quantum computer. More like 20 years is what he's predicting. The market reacted very strongly to his comments. We could see that Quantum Computing Inc., D-Wave, and Rigetti all dropped more than 30%. IonQ fell about 29%. They made up some percentages the next day. Nevertheless, the big quantum boom that we've been seeing over the past couple months got really slowed down by this comment. Some companies made some responses. D-Wave did an interview, D-Wave's CEO, and IonQ published a response. So let's cover that now. 2 days later, on January 10th, IonQ's CEO published a comment about the current value in quantum computing. He's writing about the upcoming 64-qubit tempo system that they're planning on releasing and the different kind of fields it's going to disrupt. For example, they're predicting AI, optimization, quantum internet, networking, all of that is a short-term quantum application. So we'll have to see what's going to happen in the next couple years. But I think a lot of the people in the industry are believing that we are closer than 20 years to a useful quantum computer. Getting into some more actual scientific news about quantum, there's a huge breakthrough in reducing the temperatures of different quantum computer chips. Some quantum computers need incredibly cold temperatures, while others can actually operate in room temperatures, and I'll get into that soon. What this research was able to do is, between Chalmers University and NIST, they were able to create a new kind of cooling mechanism that reached record low temperatures of 22 millikelvin. What's interesting about reaching 22 millikelvin is it's a significant enough improvement that errors that occur from heat in the system are drastically reduced. And if we couple this kind of new cooling technology with the research that we've seen coming out of Google and Quera and other companies on quantum error correction, we could actually see the kind of benefits compounding with each other. You reduce the temperatures, you have better error correction schemes, and we can see useful quantum computers useful quantum computers coming way sooner than even optimists predict. We have some cool news coming out of Japan, where they actually were able to get a general purpose optical quantum computer. And what this means is that they're actually using photons to do computation. And photons have a property called spin, and you can encode quantum information into the spin, whether it's spin up or spin down, or some combination through polarization. This computer, what's astounding, is it has computing power equivalent to 1,000 qubits, which is an insane number of qubits. I'm curious to see how sensitive those photons are. Historically, photonic chips, like out of Xanadu, are struggling to reach this kind of scale without, some cosmic ray coming in and destroying the whole experiment. So, computing at the speed of light in a quantum computer is super valuable. So I'm looking forward to seeing what research comes out of Rikken. It's a fantastic job to that whole team who created this. This is a huge step forward for photonic quantum computers, so congratulations. We have some other news that's kind of similar to the photonic chip, but in this case, they're using something called a nanoscale circuit that takes some electrons and brings them very close to each other. This is similar to how the photonic quantum computers work, where you'll take photons, move them very close to each other, and they'll interfere with each other. In this case, they're using two electrons that can move very close to each other along a nanoscale circuit. And it's close enough such that the magnetic force of those different electrons repel each other. And in this case, what they're able to see is if they repel and decohere each other and have destructive interference, it can block off or open the path for more electrons. So they're treating whether or not there's constructive or destructive interference with the electrons as waves, right, passing through. Whether those waves get bigger or cancel each other out, they're using that as a qubit. And they're calling these two electrons that interact with each other split electrons. And they were actually a theorized thing that might exist, and only, 2 days ago were shown to exist. So I'm really excited to see a quantum computer built using this. Germany has some exciting news from a company called Hensoldt that is working on quantum computing and remote sensing. Quantum sensing is one of the most important short-term applications for quantum. We've seen it used in submarines. Instead of GPS, they're able to take a quantum particle and actually devise their exact location on Earth by isolating it from everything in the sub, and it's able to keep track of where they are exactly. So there are a lot of benefits for that. You can have a boat or a plane, whatever, go completely dark to radar. It won't be sending out any sort of signal. No signal will be going to it. So there are a lot of benefits. Germany is funding this project, and they're hoping to integrate, more quantum systems into their military. We have some exciting news coming out of the UK with a partnership between the University of College of London and Oxford University. What the quantum motion was able to figure out was a way to create quantum dot qubits using GlobalFoundries' existing silicon foundries. So this is really exciting because a big hurdle that we've talked about before was creating all of the new pipelines and all of the new supply chains for creating a quantum computer is extremely difficult. If you could somehow use the existing architecture and foundries to create qubits, well, that's like amazing. And you can scale them up really quickly, in theory. Today, what we found is that they were able to create quantum dots in an integrated array of 1,024 of these qubits, which is a huge number of qubits. You could do useful, algorithms, chemistry work, all of that with this number of qubits. And they were able to do so using GlobalFoundries semiconductor foundries. So good job, Quantum Motion. We have some news coming out of Europe, and Europe is funding this consortium of silicon quantum companies called Equspace. And these companies are special because they're focused on improving the readout and the different kind of aspects that go around silicon-based quantum computing. So it's similar to Quantum Motion in that kind of joint research that they have. But in this case, what they're doing is not focused on creating qubits, but focused on creating the systems around it. Right now, they're going to be focused on developing scalable methods for reading these silicon qubits. They're also focused on quantum dots. So it's really interesting to see that just within a couple days of each other, right? This is starting at the beginning of February, so, a couple weeks from now. A lot of companies and a lot of governments at this point are seeing the value in using a silicon-based qubit for quantum information. IonQ finally completed the acquisition of Qubitekk. We talked about this a little bit before, but now that it's official, a lot of the quantum networking advances that Qubitekk has, developed will now be integrated with IonQ's machines. Hopefully, we'll be able to see some quantum internet, some quantum infrastructure, potentially even using existing fiber. There are a lot of these different avenues that companies are taking toward some kind of quantum utility. In this case, quantum networking is seen as a pretty strong start for quantum utility, for quantum encryption, speed of information. I think that this kind of advancement toward quantum networking has a lot of potential. Thank you so much for joining me today on this weekly recap for quantum computing news. It was definitely a crazy week. The market was doing things that nobody, I think, expected it to do. Nevertheless, there was still some great research coming out of different groups. So if you like the video, subscribe. I'll be posting one of these every Saturday. If you dislike it, let me know and dislike it so I'll improve the next one. And if you have any questions or any comments, leave them down below. I'll be sure to answer them. Thanks so much and see you next week.